Due to the coronavirus, the AP Calculus AB exam has been modified. As you should know by now, there are only 2 questions. And these 2 questions are likely a hybrid of several topics. The point of this video is to zero in on the very topics that are likely to be addressed. I will also discuss the topics that will not be on this year's AP exam. The first focus here is going to be on what we have called this year Q304. It was formerly Q401. This unit consisted of 4 lessons. Lesson 1A. This lesson was on derivative analysis, where we make statements about a function based on its derivative. These statements include identifying where a function has a local max or local min. That's where we say derivative goes from positive to negative and equals 0, etc. Intervals where the function might be increasing or decreasing. Intervals where the function might be concave up or concave down. Points where we have a point of inflection. Also, a big one here is the absolute max on a closed interval. This one's a big deal because we utilize the fundamental theorem of calculus part 2, where the integral from a to b of a derivative is its antiderivative at b minus the antiderivative at a. We've had extensive focus and practice on this, so I hope you feel comfortable with Lesson 1A. If not, please go back and watch the video. Lesson 1B. This is where we first introduced the fundamental theorem of calculus part 1, where we have the integral from some constant a to the variable x, and then we have a dummy variable that temporarily holds the place of x. The fundamental theorem says this is the antiderivative and this is the derivative function. The main consequence of this is that g prime of x is simply equal to f of x. And then the problems in this section, you are given a graph of the function f of x, and you are to know that it is the derivative of the function g of x. G of x you can't see. You can only see f of x, the derivative of g. Lesson 1b has you find things like g of 2, for instance, and then that would be the integral from a to 2 of the function, and now I can use x, and then you would appeal to geometry to find g of 2. But you would also find all of the other things that we found in Lesson 1a, local min, local max, point of inflection, absolute max, absolute min on a closed interval, just to name a few. The reason that Lesson 1a and 1b are so important is because not only do they utilize the fundamental theorem of calculus part 1 and part 2, the area integral connection, they also utilize a lot of the derivative concepts that we learned from the beginning of the year. So these questions in this unit are inherently hybrid questions automatically. So I can predict with high probability that you will see a question similar to these. I'm going to skip to lesson 3 now here for a moment, because this also deals with the fundamental theorem of calculus part 1. The difference was we added the chain rule to the discussion. So an example of that might be g of x equals the integral from, let's say, 1 to x squared of f of t dt. And the consequence of that was that g prime of x was equal to f of, and then we had stuff. We took this and plugged it in, and then we multiplied it by the derivative of stuff. That is the chain rule. I would encourage you to rewatch Q304 Lesson 3. I really think there's going to be a lot of questions in regards to this. There's also a practice problem in this lesson that you can redo and recheck your answers. Now to Lesson 2. The fundamental theorem of calculus, I will state again, is the integral from a to b of f prime of x dx, which is f of b minus f of a. And in Lesson 2, we are approximating the integral from a to b of f prime of x dx utilizing one of the approximation methods. Perhaps it was right rectangle approximation, left rectangle approximation, midpoint, etc., etc. Maybe we're using trapezoid approximation. And all of these are considered Riemann sums. Now let's move on to the second main focus, which is going to be Q302, which our book was chapter 6, and this was on differentiable equations. A typical differential equation question that we have dealt with is one that looks like this, where the main idea here is we will separate, integrate, algebrate, solve for C, and then isolate Y. Unfortunately, I don't think it's possible, but I don't think they're going to do this type of differential equation on this year's exam because you can easily integrate on a calculator. So I have a feeling that this one is not going to be on this year's exam, but there are going to be plenty of other differential equations and topics from this chapter that will be on this year's AP exam. So here is another differential equation. This is the type you will likely see. What makes this different is that the derivative equation is not separable. You can't isolate y on one side while getting x and dx on the other side. So what are the type of questions they will be asking in regards to this? Well, let's discuss it. Linear approximation, I'm telling you, know it and know it well. If you recall, we've discussed it 100 million times. Y minus f of a equals f prime of a, that's the slope, x minus a, and then we often wrote it as L of x equals, and then we added this to both sides to get f of a plus f prime of a, x minus a. That was the linear approximation. We extended that in this unit to be f of a plus f prime of a comma b because the slope would depend on an x and a y coordinate. So that is something that you will definitely see here. To give you an example of that, if I'm finding the linear approximation of my function f here, then we need, let's say it's centered at 1, I'll need f of 1 plus I'll need the slope at 1 comma the y coordinate, and I see from the condition that the y coordinate is 5 times x minus 1. Filling this in further gives me 5, I know that, plus, now I determine the slope by plugging 1 in for x and 5 in for y. 5 squared is 25 plus 1 is 26, x minus 1. So there's the linear approximation, and I can approximate f, let's say f of 1.2, that's going to be approximately the line at 1.2, which is 5 plus 26. 1.2 minus 1 is 0.2, and whatever answer this is would be the approximation. Definitely know that. The second derivative is a big deal here as well. So if I find d squared y dx squared, we're going to employ implicit differentiation. That's the derivative of the derivative. Here we treat y like stuff. The derivative of x is 1, but the derivative of y squared, think of it as stuff squared, would be 2 y to the power of 1, but then times the derivative of the stuff dy dx. That is a very important part of this. And so if I'm trying to find, let's say, f double prime at 1, well, f double prime at 1 will be f double prime at x equals 1. At the same time, y is going to equal 5, but also at the same time, dy dx, as we found earlier, was going to be 26. And those are the items that I would plug in to the second derivative equation. That's a large number, but that would be the result of the second derivative. That relates to concavity and also relates to the over or under estimate of the linear approximation. You could also be asked to draw a slope field or maybe draw a solution onto the slope field. I'll ask you to refer to the video if that seems foreign to you. And finally, be prepared for L'Hopital's rule. So here, if I'm trying to find the limit as x approaches 1 of f of x minus 5 over 2x minus 2. You can see here that L'Hopital's rule is going to apply. If I plug 1 in for f, I get 5. And so the numerator is equal to 0. and the denominator equals 0. We never want to say equals 0 over the 0, so I had you put these funny curly brackets to indicate that it's approaching 0 over 0. We probably in our best interest to write L'Hopital's rule. Now, the AP said they wanted you to write two separate statements here. The limit as x goes to 1 of f of x minus 5 equals 0, and the limit as x approaches 1 of 2x minus 2 equals 0. There was literature that said you should write both of these separately, not equals 0, 0. Never say equals 0 over 0. But I've talked to readers that say you might not have to write both of these statements, provided that you do some indication of L'Hopital's rule and also use the word L'Hopital's rule so the reader clearly knows what you're doing. Anyway, I'll finish this out. So this is the limit as x goes to 1. The derivative of the top is f prime of x, and the derivative of the bottom is 2. And we found already that f prime of 1 was equal to 26 over the 2 is equal to 13. So be prepared for a hybrid question that relates Q302, Chapter 6, and Q304, Chapter 5b. I will write some questions that I feel are a hybrid of the two. Know these and know them well. It would also behoove you to look at Review Assessment B and Review Assessment C again. So what is not on your AP exam? Well, the clearest item is Q402, Chapter 7. This was the last thing we did. Some of you took a test, some of you didn't. This was where you found the area between two curves. That's where you also found the volume after revolving a rectangle over the x-axis. All of that stuff, cross sections, arc length, all of that stuff is out. No Chapter 7 area volume type questions. Now, the next item out actually hurts my feelings. Particle movement. These were questions like, when is the particle moving to the right? When is the particle moving to the left? When is the particle speeding up, slowing down? What is the position of the particle at time 5? What is the displacement of the particle? All of those questions are out. Unfortunately, I think we're very good at those, but they've been eliminated. The other one, which is not perfectly clear, I'm sort of interpreting this, the rate in minus rate out. Those are context of the accumulation function, indications that those are out as well. Basically, word problems. A lot of fundamental theorem of calculus, a lot of integration application, but not so much the word problems. Now, these can be found Chapter 5a. This one was Lesson 2a, and this was Chapter 5a, Lesson 2b from Q303. I do still think there's some benefit to looking at lesson number 1a and lesson number 1b as they do area integral relationships. They also focus in on the fundamental theorem of calculus part 2. But if you are able to do the stuff that I told you to focus on, then you should have a very high comfortability level with this, so you probably do not have to go back and review Q303. Another item that is out would be the average value. That was integral over interval. That is out. It's a little deceiving, though. You got to be careful. That doesn't mean average rate of change is out. Average rate of change is clearly in, and that's the change in y over the change in x. That's very important, and that relates to the mean value theorem, which you should absolutely 100% know. I would also encourage you to know the intermediate value theorem. Now, there are some lingering topics like related rates. Could you have a related rates part? Well, you could, and I feel like at this point, if you don't know related rates, you're probably just going to let that one go. Another potential part could be finding the derivative of the inverse of a function. These would be low focus, but maybe addressed in a very simple manner. I will create a bunch of questions that try to tie in all the topics that I think will be high focus. Please, in this last lap, last 2 weeks, give it your best effort. I know you can do it. I miss you all. Goodbye.